So let's try it again, right? So we're going to do another ordinary truth table to determine if now this argument is valid or invalid, right? So we have two premises, tilde d wedge e, tilde c wedge e, and then therefore c triple bar d. And so just notice here, of course, again, three different letters. I have not written them in alphabetical order because D came first here, so I've just done it that way. And so again, three different letters means an 8-row truth table, which you see here. And the first step, before you get going anywhere, right, with this, is you always want to make sure you identify the main operator columns for each of these statements here. So the wedge would be the main operator here for the first claim, right? The tilde only applies to the D. There are no parentheses there. Same thing. In our second premise, the wedge is the main operator. And then, of course, finally here, the triple bar is the main operator for our conclusion. Now, as I indicated in talking about 5.3, when we're doing ordinary truth tables, we want to be looking for ways to speed the process up, right? And so as we looked at in 5.3, one of the ways to do that is to copy over the information column-wise, and we will do that here in just a second. However, there's a very important tip here to give you when it comes to doing an ordinary truth table to determine if an argument is valid or invalid, and that is this. Always start in the conclusion. Always start at the conclusion. So I'm going to start working out the conclusion first. I'm going to work out all of these values here first, and then proceed. And I'll explain why after we do go ahead and work out that main operator column for this statement here in the conclusion. So we're looking at C and D here. So just note that C is in the middle column of information there. So we get true, true, false, false, and so on. And then D was the first column. So we'll get 4 trues and 4 falses there. So this is great practice then again for the triple bar, and all we have to do is remember that when the two sides match, the triple bar is true, and when they're different, of course, then it is false. So they match, true, different, false, different, false, different, false, different, false, and then look, they match again, so they're true, it's true, and they match again down here in the 8th row, and so it's true there as well. So we get, for our conclusion, 2 trues, then 4 falses, and then 2 trues. Okay, but here is why we always want to start in the conclusion when we're trying to show if an argument is valid or invalid, right? And it's simply to remember this. What's the whole point of this process? The point of this process is to see if we ever get a row where we get all true premises and a false conclusion. Well, with that in mind then, right, what are the odds of the first row being a row where we get all true premises and a false conclusion? And of course, the odds are 0, right? There is no chance that we're going to get all true premises and a false conclusion there. And so, you know what? We don't have to work out the first row in the premises. We don't have to work out the second row in the premises either, for the same reason. 7th row is also worthless. 8th row will be a waste of time. So we don't need to work those out. And so what we can recognize here, hopefully, is that we've just saved ourselves some work. All right. So in other words, I'm only going to worry about these middle 4 rows here when it comes to working out the premises. So with that, let's go ahead and go to the first premise here where we have D, true, true, false, false, and then C, false, false, true, true, right? Just copying over this section, that chunk of information here. Before we work out the wedge, let's take that tilde though, right? And the D values get plugged into the tilde before the tilde gets plugged into the wedge, right? Just to note that order of operations there. So we have true becoming false, true becoming false, false becoming true, and false becoming true. All right. So what we're going to do now is take false, wedge, false. C is getting plugged in there as well. False wedge false. False wedge false. That is false. Second, or this other row here, it's actually the fourth. False wedge false. Well, that's still false. We go down to the fifth row. True wedge true is true, and true wedge true is true. And guess what, right? Again, the whole point of this is asking ourselves, can we ever find all true premises and a false conclusion? Well, right away now, the third and fourth rows are out of the running. And so once again, we have cut our work down a bit. So now, when it comes to this second premise here, this last premise, we're just interested in what looks to be the fifth and the sixth rows to see how they turn out. So let's get that information here. We have C is true and true as well. And then E in those rows would be, we're talking about the, again, fifth and sixth rows, true and false. The tilde, let's do that order of operations to make that clear. So the C plugs into the tilde plugs into the wedge, as does the E, just like we saw before. So these two trues become false. And now we're looking at false wedge true. False wedge true is true. Now, again, if I had invested in sound effects, I would have some sort of ringing sound right now, because as I hope we all recognize, what we have just found is a row. That premise is true, that premise is true, and that conclusion there, and that row, I should say, is false, right? And so what we would do, and I've just highlighted there the main operator values, but another way to do it is just to circle that row and indicate that row shows the argument is invalid. Clearly, I did not need to work this value out, because even if it turned out to be true, it's not going to get more invalid, right? It's either valid or it's invalid. And clearly, since it is possible to get all true premises and a false conclusion, it's as invalid as it's going to get. So my point here is that, as you can see here, we left a whole bunch of trues and falses out, right? We didn't need to develop them or work them out because they didn't matter in terms of finding all true premises and a false conclusion. Now, of course, if an argument is valid, you'll have to end up doing a bit more work. But anytime you have an invalid argument, right, you can certainly save yourself typically at least a little bit of work. And in fact, I will just say, if for whatever reason the very first row you work out is all true premises and a false conclusion, you can stop, because that will be enough to show that it's invalid, right? Having said all that, we are going to be moving next to indirect truth tables and discussing them in 5.5. But when I ask you to do an ordinary truth table, as we've just done here, right, remember, you need to provide this pool of values so I can see that you know how to set this up. That doesn't mean you have to work out every single T and F over here, as I hope I've made that clear. But I do need to see that pool of values so it is clear that you know what would be necessary to plug in here to make this process work.